Well, hello. Hopefully I'm not the one guy who's standing in between beer time and you guys. But first things first, if you have a question during the meeting or a remark, shout it out. I'll try to give you an answer or at least try to cope with a straight shot at me. So who am I? That's already done, so we can skip that slide. But still, I guess I need to answer you something, and that's why I am talking about this. Because I guess nobody knows ZITADEL because we're still a small company and a relatively young startup. So we're like 3 years old. And what we basically do is like we try to attack off zeros and key cloaks. And to lay out what we do, I provide one slide, and it's really one sales slide, not more. And I'm sure of that that's fine with you guys. So that's what we do. We think we are the combination of both worlds. Hopefully everybody knows the fusion dance. Raise your hand if you don't. Oh, I see. Not so much. Well, okay, like 30%. So that's what we do. Okay, so serverless. I guess everybody nowadays knows what serverless is, more or less. And I'm trying to define shortly what we think serverless is and how it looks. And primarily, it looks like that. Because all of those funny things can be defined as serverless to some degree. I mean, you can run your OpenShift cluster, and you need to maintain nodes, and you can pop native on top, and whatever you feel is necessary. But what I want to point at is like the serverless part there is like the least mature of the whole ecosystem. Like there is not so many bells and whistles around that, and I will tell you why in depth in this talk. So the main driver why we actually switched to serverless is because we had some questions. And actually it boils down to 2 questions. And one is, okay, how can you deploy a service globally close to your users without breaking a bank? And I'm making an example here. So a GKE cluster, for example, costs roughly $70 a month to just run the control plane nowadays, since Google got rid of the free tier there. And if you run like 9 regions or 26 or whatever the arbitrary number is, you have quite a high base cost. And that's kind of a main driver for a young company, because you don't want to spend your money too much on just having a GKE control plane. And so we thought, okay, is there something we can do about that? And the second main reason is, okay, we want to provide low latency and as well high availability. That's kind of the main drivers we asked ourselves. How can we proceed and switch from Kubernetes, which costs quite a lot in regard for the service we provide, and how can we still adhere to those 2 questions? So I already got ahead and asked, Kubernetes. Yeah, it's a great tool. Maturity is really high. I mean, the Kubernetes environment is really thriving since the last few years. And actually, we really liked Kubernetes. So it's not like a dislike choice, to be honest. It's not like we don't like it. But it's a beast. You can do so many things with it, and that becomes a complex operational burden at one time. And I'm not just talking about running nodes and running Kubernetes in general, but eventually you need tools on top. You have an Argo CD, you have a Grafana, you have a Loki, whatever deems your case. And so you have so many moving components distributed across so many regions that gives quite a high base cost at one point. Serverless Kubernetes is strange to me. I'm mainly looking at Azure ACI, if somebody knows that, and the newly-ish GK Autopilot, where you don't provision nodes, but instead just order compute. With each pod, something is started, you define what CPU you want, and magically it scales. You don't see it, and there is a drawback to that, which I will shine a light in a minute. Big reason is base cost per pop. That's what we call it, the problem. It's what we define as how much money do we need to spend to get close to a certain region or to certain people. And in the past, that was roughly, to give you an indication, $2,000 per pop per month. So it's quite a lot if you scale that across the globe. And so that was kind of a big trigger to us to look for alternatives in that scale. And as well, I'm not sure whether you know how a login system works, but we got bursty traffic all the time because we have a lot of CPU time needed for doing things like password hashing. And so scaling is kind of an important decision to us, or an important factor. And yeah, Kubernetes scaling is not like the fastest in the world. You over-provision quite a lot of infrastructure to cope for fluctuations in your traffic demand. And that's kind of important when you run a global service. So what are the alternatives? It boils down to mainly two things: functions as service and container as service. It's kind of an arbitrary discussion here. What is what? We ourselves define it as a function is something that you throw in your code, and a container is basically you have the code already there and you throw the image somewhere. That's kind of the difference we make there. But there is more to it. Let's call it serverless containers for the moment being. So why serverless containers? It boils down to these points. And the big thing there in regard to why not just a function as a service is concurrency oftentimes. I mean, there are not many providers that actually allow concurrency in function as service services. So that's, it gets worse with the pricing there. Fast scaling was really important, and so if we use some kind of serverless offering, we should be able to just pop in something, a binary on an image, and it should scale fast immediately. That's really important to us. That scale to zero could be a thing, at least in our time, or at least in our thing. For us, it's a real thing, because as time zones cross the globe, our traffic profile really changes in regard on, and that certain regions do not have any traffic at certain point in time, and we can switch them out of the load balancer and scale them down to zero without any cost. And so there is no base cost attached, which makes up for a low base price, which is what ultimately is interesting to us. We could reuse existing binaries. By that I mean, like, we have a software, ZITADEL, that's built in Go. It's one binary, you can pop it anywhere. And it was kind of important to reuse something that is not only running in our cloud offering, but also can be run by others. It's an open source project, so everybody can run ZITADEL on their own hardware. And we wanted to reuse that already tested and released software, because otherwise it makes no sense to us. And also keep things KDS compatible, because we have customers run ZITADEL on their own infrastructure, and we want to really allow for that. So that's kind of the reason why we switched to serverless containers. So now more the funny part, because the rest was just context. And now I'm going down why we chose Google Cloud Run ultimately in the end. It's not like the perfect product, but it's better than the others. And I'll tell you why. So let's start with why not Microsoft? And we tried and tested Microsoft. And main reason being, and I'm being frankly here, is kind of that Azure's load balancer offerings in 2022 do not support HTTP2 in the upstreams of the load balancers. And it's kind of a deal breaker, because ZITADEL allows for gRPC APIs. I'm not sure whether you know gRPC, but it's just a more modern API design, and it needs HTTP2. So that was a big deal breaker, and actually, after that, it was clear we do not need to investigate with Azure anymore. Let's proceed to AWS, because they have a lot of container offerings as well. And that's kind of the funny thing there. I mean, hopefully anybody has seen that tweet. I mean, there is like too many options with AWS on how you can run a container. That's not a bad thing, to be honest. But the problem is, how do you find out what offering is supporting what protocol, for example, on the load balancer side? Because AWS's ALB supports HTTP2 in the upstream, but not with every container offering they have. So for example, AWS Fargate is somewhat experimental with HTTP2. And so, deal breaker again on that end. And that's why we ultimately went to Google, because Google Cloud Run already supports HTTP2 in the upstreams. There is a catch to that, and It's actually a big one depending on the language you're using, and I will come to that in a second. Yeah. Okay, so how did it go? I mean, yeah, it's clear we use Google Cloud Run, works like a charm, but there is a journey to that if you want to be able to run a solution that's already there on a serverless container offering. And so, yeah, we switched from GKE to Cloud Run. It seems easy. It's not so much plug and play as you could figure. Because, and I will try to outline all the things that are painful during that transition. And I mean, one of the main things many applications struggle at day one is, okay, Cloud Run only allows for one port to be used. It's not like in your Kubernetes environment where you have like, oh, I can route 10 services towards my deployment or my stateful set. It's like one port only. And it's important because the health check logic is kind of different in Cloud Run. As soon as the port is opened by your application or the listen is working, Cloud Run sends traffic towards your pods. So there is not like a thing with active health checks as we are all used to in Kubernetes world. It's only just when your application listens, you get traffic. And it's that one part. And it's really important to remember that because I know so much software which cannot work with one port. That becomes especially funny when you're having multiple services in an application. For example, if you run normal HTTP traffic aside with a gRPC API or a gRPC web API and a REST API and so on and so forth. Because at that point, you need some discrete logic to separate out what traffic is actually intended to be used on that port. You could go ahead and run N versions of the same application with different needs, but ultimately that breaks the scaling model. So Google Artifact Registry is required. Maybe that's a deal breaker for you, maybe not. For us, it's not really a problem. So you can't really just pull the image off Docker Hub. That's not working. You need to push the image to the GCR. So it's kind of a nuance. It works. No more kube, whatever we want to call it today. No exec into containers and stuff because the container is just running somewhere on a magic ground. And one thing that gets strange is if you need to do something like leader locking. Have you ever heard of leader locking? It's kind of when you run multiple containers in a cluster and one container of it needs to do certain stuff and needs to be elected as a leader for certain operations. It's not so easy in a Cloud Run environment. And I'm telling you why. That's basically unique IDs per pod are not really straightforward as they are in a Kubernetes environment. In Kubernetes environment, you just can use the pod IP or the host name, works like a charm. In Google Cloud Run, you don't get any guarantees. So I'm not sure whether they are unique or not. Nobody really could answer yet that question. But the thing you need to do is like you need to use the metadata server of Google. That can be used with a GCP VM as well, but you need something that tells you what the unique ID of your application is or the instance of it. And the main reason for that is if your application does at least crypto stuff or needs to be able to generate some IDs, you need to be able to be sure that the ID of the running environment is unique. So for example, we use internally a thing called Sunnyflake. It's a distributed way of generating IDs without a central orchestration system. And we are really in need for a unique ID per pod in that example. So to make that work, use the metadata server, but that gets funny code because you have such funny things. At startup of the container, you need to call something to figure out what's my actual ID, and it makes strange nuance if you need to do that. It's not a bad thing, but you should be aware of that. And that's my main reason to giving that talk. There is more funny things. I mean, mind the cold start. Maybe that's a problem for your app, maybe not. Maybe you can live easily with 100 milliseconds or 1,000, where at startup, that is depending on your language and size of an image, something that's great. One thing that will and can go wrong is if your application does verification at startup. So for example, when your application is verifying the database scheme is correct at startup, yeah, that takes an additional toll on the startup latency, which can be a problem if you have a bursty traffic profile where you need to scale really fast. And that's kind of important to know because you need to design your application with the thought that it can be disabled to check something at startup. That's something you need to address in your application design. Still, the scaling of Cloud Run is just way faster than anything else we have seen, except Cloud Functions. That's really the only thing we saw that scales faster. So networking, I mean, maybe there is a networking guy. H2C is HTTP traffic without any TLS. In the first place, it was never meant to be, but it is in reality, because in Cloud Run, you have the TLS connection being terminated by a sidecar, and so your application needs to be able to accept unencrypted HTTP traffic. And H2C, depending on the language, is really like pain. For example, for all of you who use Go, it's a pain to configure the mux correctly, that it works out and decides on its own where the traffic needs to end up in a certain pod, because yeah, it's just not real mature, that framework. VPC connector is like a funny thing as well, because if you want to have outbound connectivity made from a specific IP address, for example, like that you are sure your traffic is sent to your customers with a certain IP, you need to have a VPC connector, and the VPC connector is somewhat strange, I would argue, because it kind of provisions a virtual machine inside your Google project. So it's really like, it runs a proxy inside your Google project where the traffic from your Cloud Run function is aimed towards, and then the decision is made on where the traffic needs to be routed at. It's not itself a strange thing, but to be honest, the box on the lower side is the problem, because the VPC connector currently can only scale upwards. And so as your traffic grows and fluctuates, yeah, your network appliances grow, but they never go back. So it bolsters some of that base cost back that I initially mentioned. Because it's VMs that are running in the background, and they cost real money. So VPC connectors are really like the main Achilles heel of that networking problem. It's not like a deal breaker, but it's not really nice. Pricing-wise, yeah, you can decide with Cloud Run whether you want to pay for requests or compute time. We took the liberty of using compute time because we use quite a lot of CPU for password hashing and stuff, and generating access tokens and all of that thing. So it's crypto operation, takes a lot of CPU. So we pay for compute time, works really well. One thing to say there is you need to really set budgets and rate limits, because things can get funny really fast, because oftentimes developers try out your system, send some APIs requests, something gets stuck, 10 servers start bombing your API, and your cost will just go upwards quite fast. And so rate limits are kind of important there. There is a great function in Google Cloud Armor. You can define rate limits by IP, so no real problem, but you need to do it. Otherwise, you will hurt yourself in regard of a price. Scale to zero is great because, if you don't use it, you don't pay it. It's for a startup like ours, it's like the perfect model there, right there. Tooling, we don't need to change much on that end. So we used Terraform with GitOps before, with Terraform Cloud, to be honest. And we just could plug in and plug out the Terraform modules, like replacing the Kubernetes stuff with Cloud Run. We could keep the rest, so it's kind of an easy transition on that end. You just need to figure out a little bit on the dirty ends on how the Terraform Cloud Run module is actually working, because there are some strange details in regard on how you mount variables and secrets, but other than that, it's quite fine. On the upside, observability-wise, what's really great there is like you get free traces from the Google load balancer toward your Cloud Run function. So you have a lot of observability data from the start without paying too much for it. And if you want to instrument your application, yeah, you can just use Google Cloud Trace or whatever tracing you deem ready for the job. And that's really like a low entry bar for having great observability with the infrastructure there. So now, I know I'm ahead of schedule quite a lot, but I think a discussion is due at the end. You left me kept talking. So I want to boil it down to that. Serverless is great if you run a geo-distributed and bursty business. If you only geo-distributed and not bursty, you can make an argument because, the gain from an economical perspective is not that high. Because if you run like 3 fixed clusters, you're fine, not much interaction. It's fine. If you have bursty traffic, yeah, definitely. Go towards Cloud Run, in my opinion. It's way easier of operating at scale than anything other you can do. Also, it's important to mention, since Heroku closed its stores with its free tier, developers should consider using Cloud Run for funny side projects, because there is a free tier to use. And basically, you can deploy anything in there. I mean, I wouldn't deploy a big Java monolith, not while Java bashing, but because of the resource consumption and the startup times, because that gets hideous. But for side projects, to just run some small application, it's actually perfect. Just pump it in there, and off you go. You do not need to care about anything. Right? What's really not great at the moment is, there is no real service discovery. It can be a deal breaker for some if you have a distributed architecture with many different services. It's a deal breaker, I'm sure. It's not great for complex workloads. So if you need GPU to have machine learning accelerated or something like that, don't go there. It's just not there yet from a maturity standpoint. And if you're used to have a high level of flexibility, like, okay, I just want to start a toolbox container, a sidecar to my Kubernetes deployment, and I want to try to fiddle around, and I want to look at the IP tables or whatever you want, don't go there, because it's hidden beneath so many abstractions that you don't need to take care of it. And so it's really like, if you need that, don't go there, because then at that point you're better off using a Kubernetes derivative, whatever you use, because you get the flexibility you need with the added cost and maintain effort. So that's kind of the real conclusion there.